Okay, so for a gravity problem, we're going to look at the time it takes for an object to fall. So I've taken some data about Mars from the website that's indicated here. It's got a radius of 3,400 kilometers and a mass of 6.4 times 10 to the 23rd kilograms. I've said it takes about 0.6 seconds for an object to fall 2 meters on Earth. You don't need that information for this problem. It's just to give you something to compare it to. That's something that we observed actually in class when we were trying to measure the acceleration of gravity. I've asked how long it would take the same object to fall on Mars, neglecting air resistance. That's really what we want to find. We want the time it takes to fall, so we know the distance, and we want the time. Now, the only way we can do that is from the equation of something falling with free fall, distance fallen with zero initial velocity, and that's going to be distance equals 1/2 at squared. And for the purpose of this, we can say it's 1/2 gt squared, because the acceleration is the gravitational acceleration of that planet. So now what we need to find is g, and we should be able to solve for time given the distance of about 2 meters. On Earth it's 9.8, and if you plugged in everything else, you'd get about 0.6 seconds on the Earth, but we don't need to go through and solve that problem. However, we do have an equation that relates little g, which is the gravitational acceleration of a planet, to its mass and its radius, and that is, we'll use the equation again, g equals big G, which is the universal gravitational constant, times the mass of the planet, which I'll put a p down there, divided by the radius of the planet, and that's squared. So it's the radius squared of the planet. So there's the planet, and then it's squared. And that should be equal to, in this case, 6.67 times 10 to the negative 11th. It's a fraction. And that's times, I guess we can put that in parentheses so it's easier to see. And that's times the mass of the planet, which is, for Mars, 6.4 times 10 to the 23rd. And the radius of the planet. Now, for the radius of the planet, be careful. It says 3,400 kilometers right here, as you can see. But radius needs to be in terms of meters. So that's going to be 3,400 with 3 more zeros to turn it into meters, or 3.4 times 10 to the 6th, and that's again squared. So I think we'll need our calculator for this one. This will be tough to do without a calculator. Here it comes. All right, so we take 6.67 times 10 to the negative 11th, and that's times 6.4 times 10 to the 23rd, and that's divided by 3.4 times 10 to the 6th squared. And that gives us 3.69. So little g, or the acceleration of gravity on Mars, is 3.69. That's meters per second squared. So when we go back to this equation, which is the distance for free fall, we can make time the subject of the equation. And so time is going to be equal to, that's actually going to be the square root of 2d divided by g, which is going to be equal to the square root of 2 times 2 meters divided by 3.69, and that's meters per second squared. And I'll leave the second in there, the units in there, so you can see that the final answer is going to be in terms of seconds, because the meters cancel out, and you get the square root of seconds squared. So we get, in essence, we'll need the calculator. In essence, we get, that's 3.69, so we get 4 divided by 3.69, and then we take the square root of that, and we get about 1.04 So how about that? It takes 1.04 seconds for an object to fall 2 meters on Mars.